Hello and welcome. In this video, we're going to learn about the quotient rule and how to find higher order derivatives. So our goal in this lesson, I can use the quotient rule to find derivatives and I can find higher order derivatives. Let's go ahead and jump right in. Just like with the product rule, I'm not going to go into depth on why the quotient rule works, but it comes from the limit definition, and I can show you that if you want to see it in class, just let me know. The idea behind what the quotient rule actually says and how to use it, which is what we're going to focus on in this video, is really similar to the product rule. So we're going to be looking at dividing two functions. So I'm going to use color to identify which is which. So when we take the derivative of the division or the quotient of two functions, we take the derivative of the numerator multiplied by the denominator staying the same. We subtract, because quotient always goes with division, the original numerator, not the derivative, times the derivative of the denominator, and we divide that by the original denominator squared. So this is called the quotient rule. So when you see the division of two functions or you see a fraction, this is a rule or a strategy that might help you work through it. So you need to identify each of the functions, the numerator function, the denominator function, and you need to apply this particular rule. So let's go ahead and look at this example. In this case, I have my numerator, which is 3x squared. So I'm going to be looking at the derivative, f prime of x. The first thing I'm going to do is take the derivative of the numerator, which is going to be 6x. If I take the derivative of 3x squared, I get 6x. The derivative of negative 2 is 0. And I'm going to multiply that by the denominator, not the derivative, but the denominator itself. I'm going to subtract the original numerator, and I'm going to multiply that by the derivative of the denominator, which in this case, the derivative of 2x is just going to be 2. The derivative of 3 is going to be 0. And we're going to divide that by the denominator, 2x plus 3, quantity squared. Now we're going to simplify just a little bit. That's not really the focus of this particular lesson. It's just about how to use this. But if we distribute in the numerator here, we're going to get 6 times 2, 12x squared plus 18x, and I'm going to multiply negative 2 times each of these, so minus 6x squared plus 4 all over, and I'm not going to expand the denominator here. And then if we combine like terms in the numerator, we're going to get 6x squared plus 18x plus 4 over 2x plus 3 quantity squared. And we're going to leave it just like that. Let's look at a few more examples. So we're going to use the same idea here, identify the function in the numerator and the denominator so that you can find the derivative using the quotient rule. So f prime of x is going to equal the derivative of x squared is 2x times keep the denominator the same minus keep the numerator the same. The derivative of cosine of x is negative sine of x. And this is all going to be divided by the denominator squared. And I'm just going to clean this up slightly. This is 2x cosine of x plus x squared sine of x all over cosine squared of x. Now for number 2, just a reminder, your life is going to be so much easier if you can use algebra to rewrite this using rational exponents so that you can apply the power rule. I'm going to encourage you to pause the video and try and work through number 2 on your own, and then unpause the video and see how you did. So here we have 2/3 times x to the negative 1/3 times the quantity x cubed minus 1 minus x to the 2/3 times 3x squared, that's the derivative of the denominator, over x cubed minus 1 quantity squared. And we're not going to simplify this at all. We could distribute and combine like terms, and that might make it easier if we were going to take the derivative again, but for right now, we're going to leave it just like this. Let's look at a couple more examples. All right, I'm going to encourage you to pause the video and work through number 3 on your own. Remember, you can rewrite that denominator using rational exponents. Then unpause the video and see how you did. So here we have the quotient rule set up, and this we can clean up a little bit. I like to have my variable terms in front of my sine or cosine so that it's very obvious what I'm taking sine or cosine of. This double negative is going to become plus 1/2 x to the negative 3/2 times sine of x, since we have negative sine and negative 1/2. And then in the denominator, I'm squaring a square root, so that's going to just leave me with x. So here I have my simplified answer. Let's see if we can extend this to one more practice problem using the quotient rule. All right, so here we have a quotient that we're going to find the derivative of so that we can write the equation of the tangent line. So just as a reminder, if we're writing the equation of the tangent line, we're writing the equation of the line through, let's use a different color, this point here, we're going to have y minus 1/3 equals the slope, which we haven't found yet, times x minus 2. So in order to find the slope, the derivative is the slope, what we need to do is we need to figure out what f prime of x is, and then we want to evaluate it at this x value. So we want to know what f prime of 2 is, so we can plop that into our slope portion here. So go ahead and pause the video, find the derivative, and then substitute in 2 so that you can find the slope of this tangent line. Then unpause the video and see how you did. Now here, I actually chose to simplify my quotient rule because I knew I was going to have to plug in a number. You don't have to do this. You could obviously plug in x equals 2 up here and you're going to get something similar, but this was a little easier for me to look at. And then if I go ahead and plug in x equals 2, I'm going to get 2 over 2 plus 1 is 3, squared is 9, 2/9 is going to be my slope. And then I have the equation of my tangent line. The last thing we're going to do is look at higher order derivatives, and then we're going to wrap up this video. So we addressed this without addressing it specifically when we talked about position, velocity, and acceleration. But we can take the derivative of a derivative, and that's called higher order derivatives, if we take the derivative of a derivative. So we talked about the first derivative being f prime of x. If we had 2 of these, that means we're taking the second derivative, or 3 of them, we're taking the third, or n of them, we're taking the nth. So if I had a 4 up here, that would mean the fourth derivative. If I had a 5, that would mean the fifth derivative, etc. And really all this means that you're going to do is you're just going to keep taking the derivative. So let's look at this example here. Here's my function. We're looking for the fourth derivative. If I take the first derivative, I would get 4x cubed minus 6x plus 2. If I take the derivative of that, I would get 12x squared minus 6. If I take the derivative of that, I would get 24x. And if I take the derivative again, I would now have the fourth derivative, which would just be 24. So it's the same process. You're just going to keep taking the derivative until you get to the indicated one. Let's look at a few more example problems and then we'll wrap up. All right, here are the rest of our examples. So this problem is asking you to take the derivative twice, and again twice here because it has those 2 prime symbols, which means second derivative. Here we're looking for the fourth derivative. So I'm going to encourage you to pause the video and keep finding the derivative until you get the indicated derivative. Notice on number 2, we're already given the first derivative, so the next one you're going to write is the second derivative. All right, pause the video and work through these on your own. All right, so here are those first 2. The first derivative of number 1 is 4x, and if I take the derivative again, I just get 4. If on number 1 we were asked for the fifth or the sixth or the seventh, all of those derivatives after this one, after the second derivative, are going to be equal to 0. On number 2, we're starting with the first derivative, so the second derivative is going to be negative sign. If I take the derivative of negative sign, I get negative cosine. That's our third derivative. And if I take the derivative of negative cosine, I get positive sine. So pause the video, check over those, and then let's look at the last 2 together. Okay, I think number 4 is pretty straightforward. Number 3 has a quotient rule. So first we need to write using the quotient rule, and then since I'm going to take the derivative again, I'm going to simplify that. Now I'm going to take the derivative using the quotient rule again. The derivative of this numerator is 0 times the denominator. I don't really need to write this because I'm going to multiply it by 0, but I'm going to write it anyways. Minus, keep the numerator the same, and multiply by the derivative of the denominator, which actually I'm going to expand that out. X minus 2 quantity squared is x squared minus 4x plus 4. If I take the derivative of this, I'm going to get 2x minus 4. And now I'm going to rewrite that as x minus 2 squared squared. And then I'm going to clean this up just slightly. F double prime is going to equal 4x minus 8 over x minus 2 to the 4th power. And I just want to show you that this actually simplifies to be 4 times x minus 2 over x minus 2 to the 4th. So I could make this look much nicer and just say this is 4 over x minus 2 to the third power, because one of those can simplify away. All right, let's go ahead and wrap up this video. All right, our goal in this video was to understand and be able to use the quotient rule and to calculate higher order derivatives. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.